Hi, grade 10s. Today we are going to be taking everything we learned about medians and perpendicular bisectors and distance and applying it to more difficult problems, some that are maybe in the real world and some that are just exercises to get you used to problem solving with these techniques. So I do recommend that you have GeoGebra open, or you can at least take some notes about GeoGebra, because I will be showing you some instructions of how to solve problems like this using GeoGebra. So another strategy is that you could just mark on your note where I do the GeoGebra demonstration for each example, so that if you want to refer back to the step-by-step instructions later, you could do that. Okay, so let's start by going through the note. Now, ideally, you guys would try to fill this out before I go through it and see how much you know. But this is basically the toolbox that we have. And when we're solving problems, I'm assuming that you understand all of these facts on this first page. So this first page is extremely important because it represents everything we've already learned. And now we're just going to be applying it and using it to solve more challenging problems. So two lines are parallel if their slopes are the same. Two lines are perpendicular if their slopes are negative reciprocals. A right triangle has the following properties. So either two line segments are perpendicular, so you can find the slopes of each line and show that they're negative reciprocals, or you could find the side lengths of all three sides and show that they satisfy Pythagorean theorem. We will be doing an example like this on an example 2. If you're asked to prove if a triangle is scalene, you can just show that all side lengths are different. An isosceles has two side lengths equal, and an equilateral has all side lengths equal. Just remember, if you're ever asked to find the equation of something, you'll either need 1 point and the slope, or 2 points to find the equation of a line. Also, remember, a median is a line that joins a vertex to a midpoint. And if you're ever asked to prove a point lies on a line, which you will be, you need to show that that point, whatever it is, x, y, satisfies the equation of the line. And then if it does satisfy the equation, that means it is a point on that line. We also learned these 3 major formulas. Now notice that they involve a lot of x1s and x2s, so I don't recommend just memorizing these without understanding what they mean, because it's easy to get mixed up with all the pluses and minuses. Like here we're adding, here we're subtracting. It's kind of confusing. So just remember your bad boy, your OG original slope. This is just rise over run. You've known this since grade 9. Don't let it confuse you. This is just the change in y. So how much y changes with respect to the change in x. So how much you change going up and down divided by how much you change going left and right. Now, your midpoint, remember, is just the average of the x values and then the average of the y values, okay? You're just finding the halfway point. Now, let's remember where this distance formula comes from. Again, you will be required to understand how we came up with this formula and not just how we use it. So if you're trying to figure out the distance between these 2 points, A and B, recall that this is just Pythagorean theorem. So you're just creating a right-angled triangle. Okay, and this third coordinate would have the same x value as here and the same y value as here. So this side of the triangle is just however far apart these x values are. So it's however big x2 is minus x1. And the distance, the length of this side of the right angle triangle is just how far apart the y values are. So y2 minus y1. And then we just use Pythagorean theorem rearranged to come up with this equation. Excuse me. All right, so let's get to actually solving some problems. So since elementary school, you should kind of know this general process for problem solving. First, you want to make sure you understand the problem, okay? And in this step, you're almost always going to be graphing, okay? You want to create a graph to represent what they're actually asking you, all right? Then you want to figure out, okay, what's my strategy? You want to think about that before you just, start doing things. Now, sometimes you do need to just start figuring things out, just start finding calculations to see if any of those calculations help you. But ideally, you would be able to figure out a strategy first. And then once you've carried it out, be able to reflect. You can also verify with your graph. And I'm going to be really, really insistent on this, that you should be verifying everything with your graph and that it makes sense. Okay, so find the equation of a line perpendicular to y equals negative 3x plus 1 and passes through 6, 2. So I will be solving this on here first, just with algebra, and then I will show you GeoGebra. So the first thing I would do is actually graph this line so you can envision what this is that you're trying to find. So it's perpendicular to this line. Well, this line goes through 1 and has a slope of minus 3. So you go down 3 over 1, down 3 over 1, or up 3, left 1. Okay, so again, trackpad never does me any favors. Please use a ruler. Okay. Okay, yeah, no, go way higher than that. Okay, so this is y equals negative 3x plus 1, and I'm sure yours looks way better than mine. Okay, so now we want it to pass through 6, 2. So let's plot that. 1, 2, 3, 4, 5, 6, and 1, 2. So that's our 2, that's our point 6, 2. So our line is perpendicular to this line and goes through that. So what I would do is pick up a ruler, and if I was doing this in front of you, I would show you. Pick up a ruler and make it perpendicular to your line. Now, my trick to make it perpendicular to the line is just line the little dash of your ruler directly with the line. And then that means the part where you draw is perpendicular. So I don't know if you can see this here. I'm just taking my ruler, this is so ridiculous, and lining it up directly with the line, and then where I draw here will be perfectly perpendicular. And then you want to just slide your ruler over until it's going through the point in question. So really it's going to look like, like this. So it goes through there and it's hitting the green line at a 90-degree angle. Okay, so you want to find the equation of this line. So you want to find its slope and its y-intercept. Okay, so how can we find the slope? Well, we know that it's perpendicular to this line. So the slope is perpendicular to y equals negative 3x plus 1. So therefore, the slope is going to be positive 1/3 because it's the negative reciprocal of negative 3. And you can see that it should look like over 3 up 1, over 3 up 1. Okay, so I'm going to put a little check mark to show that I visually verified that. So we have the slope. Now, do we have a point on the line? Yes, we have a point 6, 2, and we know that it's on the line. So we can use that to find b. So we set up our equation y equals 1/3 x plus b, and now we can sub in 6, 2. So 2 equals 1/3 of 6 plus b. Sub that in. So 2 equals 1/3 of 6 is 2. So now we subtract 2 from both sides, and we actually get that b equals 0. which again looks right. It looks like my origin is 0. So my equation is y equals 1/3 x. Okay, so now I'm going to quickly show you how to use GeoGebra to verify this. So I have it set up for you here. So you start with just writing the equation y equals -3x plus 1. And then you press this to go to the geometry, and you want to place a point. So you click point, and you want to place it at 6, 2. So you just get as close as you can, and GeoGebra usually does it perfectly for you. And now you want to create a perpendicular line that goes through A and the green line. So if you scroll down, you'll find something that says perpendicular line under construct. So you click that, and notice on the bottom, it'll say click a point and a line. So you click your point and you click your line. Beautiful. It makes this line for you. Okay. So if you press your basic tool back to move, you can right click, go to settings, and you want to show the value. So that shows you the equation. And notice the equation is 0.3333x, which is the same as our answer, 1/3 x. So we are correct. Feels good, doesn't it? Okay, let's go to the next example. So in this example, we have the vertices of a triangle, and they want us to determine whether or not this is a right triangle. So let's plot our points. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so when I plot the point, I'm going to make sure I label it with its letter and its coordinates, so I don't have to keep referring up here and make a mistake. So then B is down here. Notice how I'm writing B way over here, so I don't write over where my triangle is going to be. And again, I wouldn't write C up here because that would be in the middle of my triangle. I'm writing it down here, so it's out of the way of my triangle. Okay, so now again with a ruler, please, 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 guys, use a ruler. I connect these. Coordinates. Okay, so the question is asking us, is this a right triangle? So first of all, just take a look and say, which of these angles look like it could be possibly 90 degrees? So visual check, it looks like angle C is 90 degrees, possibly. That's what we have to find out. So there's two ways of figuring this out. One is using slopes, and one is using Pythagorean theorem, so using the side lengths. So basically using slopes, I just need to show that the slope of BC is perpendicular to the slope of AC. So in other words, that they have slopes that are negative reciprocals. So check if the slope of BC is perpendicular to the slope of AC. So the slope of BC is -3 plus 1 divided by 1 plus 3. So -2 over 4. So reduce that to -1/2. Okay, and the slope of AC is 5 plus 3 divided by 5 minus 1. So 8 divided by 4 is 2. Okay, so now we need to write a sentence. These are negative reciprocals, so therefore this is a right angle. It's not enough, may I repeat, it's not enough to just say, therefore it's a right triangle. I am expecting you to make beautiful, nice sentences here that back up your statement. So how do you know it's a right triangle? Well, because this is a right angle. How do you know this is a right angle? Because the slopes of these two lines are negative reciprocals, so they are perpendicular. So we're going to say, since M of BC and M of AC are negative reciprocals, BC is perpendicular to AC. What just happened? I don't know what just happened. And oh, this is fun. Anyways, and then therefore ABC is a right triangle. That's where you should be. Oh, guys, this is fun. BC is perpendicular to AC, and triangle ABC is a right triangle. All right, now the other way is to use Pythagorean theorem. So to show that BC squared and AC squared equals AB squared, okay? So AB is our potential hypotenuse. So our guess is that AB is the hypotenuse. So we need to show, does the length of AB squared equal the length of BC squared plus AC squared? Because the only types of triangles that fit Pythagorean theorem are right triangles. So we're going to find the length of AB, BC, and AC. So the length of AB, so we do our x2 minus our x1. So 5 plus 3 all squared. Then y2 minus y1, 5 plus 1 all squared. Okay, so this is just 8 squared, which is 64. And this is 6 squared, which is 36. So you get the square root of 100. Now I'm actually going to leave it like that instead of 10, and you'll see why in a minute. Okay, the length of BC, same process. You get -3 minus 1 all squared plus -3 plus -1 plus 3 all squared. Okay, you get the square root of 20. All right, and then you do the length of AC. Okay, I challenge you to do this one on your own. So pause the video and find the length of AC, leave it as a square root. Okay, you should have gotten square root of 80. If you didn't, please make sure you see me tomorrow so we can figure that out. Okay, so now notice that the length of AB squared is just the square root of 100 squared. So that's just 100. And notice the length of BC squared is just square root 20 squared. So the square root of 20 squared is just 20. And then the length of AC squared is just the root of 80 squared. So that's 80. So notice that BC squared plus AC squared equals, so that's 80. 20 plus 80, and that's equal to 100, which is also equal to AB squared. So that proves that because it follows Pythagorean theorem, it is a right triangle. So therefore, since lengths satisfy Pythagorean theorem, triangle ABC is right. Okay, so you need to say why and make your conclusion. Okay, let's hop over to GeoGebra to show how to do this. So again, you want to go to your geometry and go to the point selector and do it in the order that it's given. So A is 5, 5. You want to do that first. So it's also labeled as A. And then B is -3, -1. And C is 1, -3. Okay, so if you're doing the slope method, you actually don't want to do a segment. You want to create lines between the 2 points. You want to do that because they only will find the slope of lines, not of just line segments. So now you just want to right click on each one and make sure that you turn on their name and value, which gives the equation of each line. Oops. I made an extra point. So undo, undo. Oh boy, how do I undo this now? Okay, this is what is the problem. I should always go to move before I want to stop doing that. Okay, so then I go right click, name and value. Okay, so there it shows the equation. Now notice the slope is a decimal, so I don't love that, but you should know how to turn that decimal into a fraction. So you can see that the slope of this line is -1/2. The slope of this line is 2, so they're negative reciprocals. Yay, all good. Okay, the other way of doing this, start from scratch here. Go to the geometry tool. Again, quickly do your points. So A, B, C. And now instead of a line, I just want to do a line segment. So I'm just creating the triangle here. And notice here under measure, I can click distance or length. And then I can just click each one and it will tell me how long they are. So then you can put these decimals into Pythagorean theorem and show that they work. So there you go. All right, one last question and then we are done the note. Okay, so show that the median from the right angle of the triangle in example 2 is half as long as the hypotenuse. So this to me, I read this and I'm like, whoa, way too much information. So I always just start by drawing. So when in doubt, just draw it out, people. Just sketch this before you even start worrying your pretty head about what it means. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so there's A and it's 5, 5. Okay, B is -3, -1. And C is 1, -3. Okay, so let's draw this triangle. With rulers. Okay, so it says the median from the right angle. So remember, angle C is the right angle. So the median is going to be drawn from C to where? So a median joins a midpoint of the opposite side. So the midpoint of AB. So before I can draw the midpoint of AB, I should probably find it. Okay, so the midpoint of AB is just halfway between the two x values. So 5 minus 3 over 2. Halfway between the two y values, 5 minus 1 all over 2. So that's just 2 over 2, which is 1, and 4 over 2, which is 2. So 1, 2 is the midpoint. And visually, I can see that that's right. So I'm going to label that as point D, just so it doesn't get overly crowded. Label it as 1, 2. So I'm going to say that that's equal to D. There we go. So D is equal to 1, 2. So it says show that the median. So I want to actually draw the median here. Show that it's half as long as the hypotenuse. So if it's half as long as the hypotenuse, then therefore DC, the length of DC should be equal to 1/2 of AB. Okay, or you could write that the length of AB is twice the length of DC. Okay, either one works. It's completely up to you which one you like better. So you just have to find the length of this using the formula and the length of AB using the formula and show that. Okay, so AB, the distance there. Okay, put your long square root. Now it's the change in the x values. So 5 plus 3 squared plus 5 plus 1 squared. So remember, that's 10. We actually already found that on the previous page. The length of AB was the square root of 100. But we haven't found the length of DC. So DC is between 1, -3 and 1, 2. So notice that 1 minus 1, they're actually on the same vertical line. That's fine. That doesn't mess anything up. And then -3 minus 2. So you get that this is 0 plus 25. So the square root of 25, which is 5. So therefore, since DC is equal to 5, which equals a half of AB, the median, and then you can just write your sentence. The median from the right angle is half the length of the hypotenuse. Okay, now you can also use GeoGebra to do this. All I have to do is plot the midpoint and create my new line segment. Okay, so I click construct midpoint, and I click the line. I want that midpoint. And then I just need to make a line segment between D and C. And then just need to calculate, measure distance, and click this line, and it says 5. So this is 5 long, this is 10 long. Clearly this is half of that. It's that simple. You just need to know how to use the program. So check your success criteria and make sure you feel confident. Thanks for watching, guys. I hope you learned lots.